this question, we've got quadratic simultaneous equations. We've got a bit of an issue though, and that's that we have this unknown constant k in one of them. What we want to do first is show this result about x and k. So this question starts off like a lot of other quadratic simultaneous equations, in that we want to make y, in this case, the subject of the linear one of the two. So we're going to rearrange, instead of 2x plus y equals 1, we're going to take this 2x and put it on the other side. So y equals 1, take away 2x. Now we're going to substitute this y into our first of the two equations. So I'm just going to write out first what we did have. We had x squared minus 4ky plus 5k equals 0. And instead of y here, we're going to use our 1 minus 2x from the other equation. So then writing this out, we've got x squared minus 4k, and I'm going to put it in brackets as 1 minus 2x plus 5k equals 0. Well, we're almost there at this point. We want to get to x squared plus 8kx plus k equals 0. So let's just expand out the brackets and see what we get. We've got x squared minus 4k, because it's 4k times 1. And on the second term, we've got minus 4 times minus 2x. So that will give us plus 8kx. And this looks good because we wanted an 8kx. Well, we've still got our plus 5k on the end as well, equals 0. And now for the last line, the x squared isn't going to change. The plus 8kx isn't going to change, but we've got minus 4k plus 5k. So that simplifies to just give us plus 1k equals 0. And now we're actually there. We've shown what we wanted to show. So for part B, we're going to use the equation for k and x that we just derived. Now we want to solve to find a value of k. So let's write out what we've got. We've got x squared plus 8kx plus k equals 0. And here's some really key information. That this equation has equal roots. And what does that actually mean for us? Well, equal roots is the case for the discriminant where b squared minus 4ac equals 0. Equal roots means our discriminant is equal to 0. A really good habit here then mathematically is to write down a, b and c so we don't make any silly mistakes. A is just the coefficient of x squared, so it's 1 here. B is 8k, because it's the coefficient of x. And C is just the coefficient of the numbers at the end, so it's just k. Now we've got A, B and C, we're going to substitute them into our discriminant and make that thing equal to 0. So b squared, and I'm going to put this in brackets, it's going to be 8k all squared. Really common mistake is to forget to square the 8 as well in a second, so we need to watch out for that. We need to do minus 4 times a, which was 1, times c, which is k. And this equals 0. I think it's a really good habit again to write it out the long way. So 8k all squared is going to give us 64k squared. Minus 4 times 1 times k, which is minus 4k, equals 0. We want to solve this to find k, so we should be factorising now. We can take out, first of all, a factor of 4 and also a factor of k from both of those terms. So we're going to get 4k brackets, that leaves 16k minus 1 equals 0. This part, well, if 4k, this itself could equal 0, that would give us k equals 0. Or the other solution is if 16k minus 1 equals 0. So that would mean k equals 1/16. There are two solutions for k, or are they? Because actually earlier I've left it off here, but we did get told that k is a non-zero constant. So actually this solution k equals 0, we need to forget about and only take k equals 1/16. So watch out for those kind of details again in these questions. For the third and final part of this question, for our value of k, which we found to be 1/16, we now want to solve the original two simultaneous equations. And we're not going to go straight back to those at the moment. We're going to use this equation here, which was in x and k, to help us get there. So our first step needs to be substituting k equals 1/16 into here. So we will get x squared plus 8 times 1/16 times x plus k, which was 1/16, equals 0. And now simplifying this, we're going to get x squared plus 8 over 16 will be a half x plus 1/16 equals 0. And actually solving this quadratic might look really horrible at the moment, but completing the square is a great idea for this one, and you'll see why when we get into it. So let's complete the square on this. And that means halving this coefficient of x to get half of a half is a quarter. And we need to square that. And then if you remember, we square this coefficient in here and take it outside. So it needs to be negative 1/16. Square this, take it away on the outside. And we still can't forget about this plus 1/16 equals 0. So this is the completed square form, but actually these two negative 1/16, positive 1/16, they cancel out really nicely. And that just leaves us with x plus a quarter squared equals 0. And this actually gives us an interesting detail about this problem, because normally in quadratic simultaneous equations, you would be finding multiple solutions, but here there's only one solution, and that's because of those two, the minus 1/16 and the plus 1/16 cancelling out. It just leaves us with this thing squared equals 0. There's no other solution to find there. Or this must mean that x plus a quarter equals 0. So that means x equals minus 1/4. And it's always really tempting at this point to just think, yes, we're done, we can go home now. Actually, we need to find the value of y as well, don't we? It is quite easy for us though, because we can now use this equation to help us. And if we plug this in to our form earlier, remember we wrote y equals 1 minus 2x. When we rearrange this to make y the subject, let's put x equals minus a quarter in there. So y will be 1 minus 2 times minus a quarter. Well, that makes 1 plus 2 lots of a quarter is a half. So 1 plus a half, or 3 over 2. So our solution is going to be x equals minus a quarter, y equals 3 over 2.